Hello everyone. This is going to be a demonstration of the Stimulator box, which is going to be able to stimulate muscle contractions via electrical activity. So what I have here are two electrodes that can then stimulate my muscles. So, as you know, muscles are electrically excitable, meaning that they can be stimulated by electrical activity. So what we're going to be looking at is how differences in voltages, as well as differences in frequency, can cause stronger muscle contractions. So what we're going to do now is start out at a low voltage and then see how increasing the voltage causes a stronger muscle contraction. So let's take a look. So right now we're at a relatively low voltage, and as you can see, my finger is twitching. What that means is that there are single muscle twitches that are separate from each other with a full contraction and a full relaxation. Now also, we can see how it's going to change when we increase the voltage. So as you increase the voltage, you're increasing the electrical activity that's going to be stimulating the muscle, and you can see that the twitches are much larger now. The twitches are stronger, so if I straighten out my finger, it is going to twitch much more strongly. So what that means is that more motor neurons are being stimulated, more motor units are being stimulated. There is recruitment to cause more muscle more muscle fibers to contract and cause a stronger contraction. All right, so let's go back down a little bit in the voltage. Okay, so now what we're going to do is see how frequency affects muscle twitches. So right now the twitches are individual, as in completely separate. It has a full contraction and a full relaxation. But now we're going to turn the frequency knob up a little bit more, and we're going to see what happens. So if we turn it up slowly, it's going to cause what's called summation. So as you can see, it's now fast enough where it starts to build up onto each other. So increase the frequency a little more. So now, it's causing a stronger muscle contraction. There isn't a full relaxation. What that means is that now it's in summation. So now that it's in summation, you have a stronger muscle contraction, but you still have some relaxation. Turn it up even more. More. Okay, so now it's essentially at its strongest contraction. There's only a little bit of relaxation here, meaning that it's in something called tetanus. But specifically because of the relaxation, this is incomplete tetanus. So incomplete tetanus means that it's at a strong contraction, but there's still a little bit of relaxation. Now turn up the frequency more. More. All right. So my fingers are now completely clenched. What that means is that it is at its strongest contraction. And that means that it is in complete or fused tension. So when it's at its strongest contraction, it has no relaxation. It is completely tense, it is completely contracted, full or complete or fused tetanus. So if I try to straighten out my fingers, it goes back to being contracted really quickly. I need to put a lot of force in order to be able to straighten out my fingers, because this is a strong contraction. So that's it for our demo today. Make sure that you study, make sure that you know the differences between these different muscle stimulation artifacts, and know when there's only or full relaxation, partial relaxation, full contraction but relaxation, but then full contraction with no relaxation. So that's about it. I'll see you next time.